All right, well, let's begin. Your next homework assignment is due a week from today, and as it already has been announced on the course schedule, class for Friday and Monday are online. So those will be recorded lecture videos. I'm going to keep announcing this project deadline for the rest of the semester until it actually happens. And so, there are other things on the schedule between homework 7 and the project. It's just that the project is an important one that should stay on your radar for the foreseeable future. So I'm going to continue to give you reminders about that. We're going to be talking about rate of return analysis today, but before we do, let's spend a few more minutes discussing the project. I hope some of you had a chance to read over the assignment description, which is available on Blackboard, and I've just now handed it out. But just to summarize what I mentioned on Friday, the main phases of the project are that you're going to be thinking about the money aspect of your career and life, beginning at graduation. And so what you need to do is take a look at what career options you'll have with the degree that you're earning, and do some research on what people in that field get paid. And there's a lot of different places you can go to get that information. There are websites that collect salary info. There are government pay tables that are available. And so if you look up, for example, what kind of a job can you get with a Bachelor's of Science in Computer Science? If you're working for the government, you go to USA Jobs and you'll see lots of postings for people with a computer science degree. And you can get a feel for what the salary will be because they mention what's the GS level. Maybe they're hiring you at a GS7. So you could look up what's the salary for a GS7. And then the interesting thing is you can go back in time and find out what was the salary for a GS7 10 years ago. And you could extrapolate that increase in pay over time into the future, so that your income is going to be different 10 years from now or 10 years after you graduate, because number one, you're going to be getting cost of living adjustments which are handed out to keep pace with inflation. But then on top of it, as you become more qualified, you may get raises and promotions that are tied to your improvements in skill. And so your income and earning power will increase over time, and of course you don't know exactly what you're going to make 20 years in the future. But the point is that this plan can be a starting point for understanding the implications of your financial lifestyle. How much you're spending, how much you're saving, and what that means for the type of retirement you can have. How big of a house payment can you afford with the income that you're going to be earning? So this assessment of expenses, this is a really important point. And every semester, more than half the people who submit the project do the wrong thing on Section 2. What they do is they create a budget. And that's not what you should do. You should not create a budget for Section 2. A budget is where you say, well, I'm going to spend $1,000 on rent, and I'll spend $100 on gas and $200 on food. It's where you set limits for yourself. And that's not what I'm asking you to do in Section 2. If you read carefully in the assignment description, what it says is you should estimate the specific costs. And there's a subtle distinction there, because what I want you to do is go find real data on how much things cost. Don't just pick a number out of thin air and say, I'm going to spend $1,000 a month on rent. No. Instead, if you plan to live in Atlanta, Georgia, and you want to be in a 2-bedroom apartment, what you should do is go online and find a 2-bedroom apartment in Atlanta, Georgia that looks suitable for what you're interested in, and get the actual cost of living there. Same thing with all of the different components of your expenses. When you think about the types of things you like to eat, do an estimate that includes those specific items. Don't just say $200 a month for food, but think of it maybe on a weekly basis. That on a given week, I like to eat out twice, and I would spend $35 each of those times, and then the other days for breakfast, I alternate between eggs on one day and cereal on the next. And so you think about the specific costs that are tied to your individual use patterns. And so then the same thing is true about cars. Don't just say, I allocate $300 per month for transportation. That's not okay. Find the actual payment for a car that you want to own. Find some actual data related to the insurance costs, the fuel costs. Now, if you're living at home or in the dorms, you may not yet have exposure to some of these expenses yourself. And so it's okay to ask other people, how much is an electric bill? But I don't want the entirety of your research on Section 2 to be, my mom said. You have to go out and get actual, reliable, citable sources of data for how much things cost. And so, on a couple of things, if you're just, if your parents can provide the electric bill to show you, then great. If they are the primary source of some information, that's okay, but I think that you need to go to the ground level truth as much as possible. In the investment section, one of the mistakes that students have made in the past is just saying, I'm going to leave all of my money in a checking account which earns no interest, and so therefore I don't have to do the calculations related to investments. Obviously, that is oversimplification, because every job you're likely to hold for your career, the employer is going to offer a mandatory retirement plan. Whether it's the federal government or private employers, you'll have a 401k or some equivalent plan, a retirement plan, where you contribute maybe 6% of your salary and the employer matches it. And then there's a variety of options that you can invest in. Maybe a blend of stocks, bonds, and other types of instruments. And so what you ought to do is start learning a little bit about, what do retirement plans look like? What are typical rates of return for a retirement plan? And there's some good places you can do that. Websites like The Motley Fool, which is just fool.com. You can learn a little bit about personal finance by reading the Wall Street Journal. I'll try and give you hints along the way on good data sources for some of these things. The one last thing I want to look at more detail is the spreadsheet for cumulative savings balance. All right, so this is kind of the crowning achievement of your project. You're going to have a lot of written information. The typical good project that earns a grade is, I guess, written text, probably 8 or 9 pages, and that's plus figures, plus charts, the text itself, 8 or 9 pages. And that's just the default spacing that Microsoft Word gives you, which I think is like 1.25, the default text size of 11. All right, so, and then what you're doing is you're explaining all of your assumptions in the written report. And then this is where you're doing the calculations. So you can see on this illustration, there's the year of graduation, the amount of income that's earned that year, the expenses, and the amount that's saved is how much you earned minus the expenses. So I'm just showing you kind of the mechanics of what these different columns are intended to calculate. And your spreadsheet has to look like this. If you want to create your own spreadsheet for calculating expenses, that's fine, but that doesn't mean that then you don't have to write about it in the body of the report. You still have to explain your assumptions in the body of the report, and your final table needs to look exactly like this as far as the column titles. So income minus expenses is how much you save. What you didn't spend by default, unless you're just throwing it in the trash, is money that you still have and have saved. So the cumulative savings balance in the first year is just how much was saved that year. But then the following year's cumulative savings balance is the previous year's balance. So it's how much you had in the account last year, plus the amount of new money that you're depositing this year. So that's the $21,500. And then this investment yield, $935, that's how much interest or growth has occurred on the previous year's balance. And so this person is assuming that their investments yield an average rate of 5.5%. That's what this cell indicates. So 5.5% of 17,000 is the 935. So at the end of the second year of this person's career, the total value of their savings, and that savings is not just a savings account, it means all their retirement accounts, their checking account, all of their liquid assets. not the value of their car or their clothes, the things that, like you could actually spend. So it's last year's balance plus this year's new earnings, the new amount that you saved, and then the interest, which is based on last year's balance. You don't earn interest on how much you saved this year because it just went in the bank. So this 935 has nothing to do with the 21,500. The 935 is just based on what was in the account last year. So you'll notice that occasionally this person has a negative savings amount. That's because this year the extraordinary expenses of $55,000, that looks like a big wedding to me. So that year the spending was more than the income. And so you'll notice that the cumulative savings balance went down from 172,000 to 150, but then it started bouncing back and growing again. So in the write-up, in your report, you're explaining things like how you are assuming the income is growing, and like what years you assume there's a promotion. It looks like some of these years, see these odd numbers here, 48,801, 50,265. That's probably the 3% cost of living adjustment. So it's just a 3% increase. But then when it jumps from $60,000 to $60,020 to $75,000, that's most likely the person is assuming that they got a raise that's tied to a promotion. And so in the report, in the income section, it's explaining things like how many raises you expect to get. Like on that career path, if you start out as a, like software developer 1, software developer 2, then a network architect or whatever the progression looks like, then you would find out, what are the salaries in today's terms for those positions. But then you'd also need to index it into the future to find out how much does a network architect make today versus how much would they make 12 years in the future. So you need to study the format and layout of this spreadsheet, and if you have any questions about how it's calculated, let's get together, because I really want everybody to get the right idea for calculating the cumulative savings balance. The one thing that this didn't continue longer, because I just wanted to bring it up on the screen now, but you need to go beyond age 46. You need to go through the entirety of your assumed life. So if you assume that you're living to 100, then you need to show that all the way through. And after retirement, maybe your income is just Social Security, and it could be that your expenses are greater than your income, and that means that you're starting to spend down your cumulative savings balance. One of the things that other common mistakes that people make is they overestimate their capacity to save. The reason why there aren't just loads and loads of millionaires among people with ordinary jobs is that you usually spend what you earn. It's very easy to spend all that excess money. And so be realistic when you are estimating your expenses and where your money's probably going to go. That said, it's really powerful when you see the effect that compound interest has. And I hope that one of the outgrowths of this project is it makes you excited to save money early, because if you save $1 in your 20s, that dollar has just decades and decades to compound and will get so much bigger compared to $1 that you save in your 60s, which is almost when you're about to retire anyway. So that's one of the few things that I did right when I was younger, is I started saving money for retirement the very first paycheck I got. I mailed in a check because it was the olden days, but I opened a retirement account with my very first paycheck, and I've consistently been saving since then. And so hopefully one of these days I'll be able to retire. Any questions about the project? Yes?
Can we get the, it's in the PowerPoint, never mind. I was wondering where we could get that Excel sheet for the example.
Mm-hmm. The columns of the spreadsheet is in your handout, and I think it is in the class notes as well. Okay, as you do have other questions, let me know, and we can take a few minutes at the beginning of each class to discuss it. Go ahead.
What year do you want us to start? Like after we graduate,
Mm-hmm.
from now?
Your graduation year. You can start now if you're already working, and if you maybe already have some savings, you can start with today if you like. But for a lot of people, they don't have income yet, so they choose to begin at graduation. But whatever you prefer is fine.
Should we calculate student loans as an expense?
That's a great question, the idea of student loans. Yeah, I think that you should, because that's something you're going to be paying for potentially. Yeah, and what some people will even do is they can include that in their assets so that actually you're graduating with a negative cumulative savings balance. But if that's just too depressing and you just don't want to think about it that way, then just consider it as an expense that you pay, and eventually you stop paying it and it never affected your cumulative savings balance. Other questions? All right. So we're going to talk today about rate of return analysis. And for the next several class periods, it would be beneficial if you bring your laptop to class. We'll be doing in-class exercises that utilize spreadsheets. Now, of course, class on Friday and Monday are online, so you won't actually come to class Friday and Monday, but you will use Excel for those in-class exercises as well. Let's use the illustration of a food truck to look at a couple of concepts. This is an actual food truck. I forget where it's located. One of the places I've been that just has an unbelievable food truck scene is Portland, Oregon. They've got city blocks with just dozens and dozens of food trucks, and it's really fantastic food. But this particular food truck, Disco Dogs, I looked up the typical cost of a food truck, and it's about $85,000. That includes the vehicle plus outfitting it with the specialized stoves and refrigerators and generators and so on. So that's a lot of money. Think about that lump sum at the beginning of initiating a business in order to get set up for selling hot dogs remotely, or I guess mobily. One of the things on their menu is the Lucky Chucky. So it's $8.50 for a hot dog. That's pretty expensive. That's even more than they charge at Hillbilly Hot Dogs, and that's kind of my high water mark for an expensive hot dog. I go there and I'm like, $4 for a hot dog, really? But I guess it's not $8.50 like the Lucky Chucky. Sounds good though. The question is how many hot dogs would you have to sell in order to cover the cost of a food truck? It's not as simple as dividing the number of the food truck cost by the number of hot dogs, because remember, it's the time value of money. So if we want to do an assessment of how long it'll take to pay off the food truck, we could actually graphically summarize what that's going to look like. And let's take a look at it graphically, and then also later in the day today, we're going to do it with a spreadsheet. And as we do, we will calculate the unrecovered investment balance. This phrase you've heard before, unrecovered investment balance, and so it's not the first time we've talked about this idea that it's how much of the money you invested up front you haven't got back yet. Okay, so that $85,000, the vertical axis of this figure, unrecovered investment balance, even though we spent some money and it's money we haven't got back yet, we'd usually draw an outflow of money down with the traditional cash flow diagrams that we've depicted so far this semester. But this is a special graph. This isn't just a normal cash flow diagram, so we're doing it up even though it's an outflow, unrecovered investment balance. And so this is $85,000. And then this blue line shows the effective interest during the first period. During the first period of compounding, the unrecovered investment balance gets bigger because not only did you outlay $85,000, but that's money you could have had in the bank earning interest. And so you want to earn a rate of return on your investment. And so this blue line shows the effect of the interest that you would be earning if you had put it somewhere else. So you just determine what is your applicable interest rate, your MAR, your minimum attractive rate of return, and you can calculate at the end of the period the effect of the principal, P, multiplied by 1 plus I prime. Now, I prime is the internal rate of return. That's some interest rate that over a certain number of years is going to cause our unrecovered investment balance to go down to 0. So that if we said we wanted to pay off this food truck after 10 years, we could find out what interest rate will it take for a certain amount of revenue each year to pay off this loan after that 10 years. So in this figure, R is revenue and E is expense. So the revenue is what you get for selling the hot dogs, and the expenses are you're subtracting out the things like your raw food materials, the labor costs, city permits, fuel, and so on. So the difference between revenue and expense is profit. It's how much you get to keep. But the profit just brings down the unrecovered investment balance. And so 1 year of profit isn't going to cover that initial upfront expense. It just brings down the unrecovered investment balance. And then it goes through the same annual cycle where, because of the effective interest, that unrecovered investment balance goes up a little, but then the profits bring it down each year. So the question is, after a certain number of years, sometimes we will be solving for how many years it takes. Other times we know the number of years we want it to be paid off in, and we're solving for the interest rate that makes that possible. So these problems can have different unknowns, but this is the type of problem we can expect to be calculating, where over some time horizon, the initial outlay of cash that you spent to begin a business, that unrecovered investment balance is coming down until finally all of the debt is retired. Now, sometimes it is that you took a loan. Sometimes you borrowed the money for the food truck, but if it was your own money, it's not a loan, but you could still calculate this figure of unrecovered investment balance because it's your own money that hasn't yet been recovered by owning this investment. So I prime will often be the interest rate that we want to determine to bring equilibrium between the inflows and the outflows. You remember the picture of the rocks that we're balancing, or the elephant that was on the beach ball? It's that same idea of balance between inflows and outflows. Okay, so today's in-class exercise, let me pull it up. All right. Today you receive $85,000 from the bank for a 5-year loan at 4% annual interest, where you'll make equal annual repayments. So, I ask you to do 3 things. First of all, draw a cash flow diagram that summarizes this problem. So it's showing the money that you get at time 0, that you're making equal annual payments for 5 years. And then I've given you the factor. Rather than having you look that up out of the table, here's the ratio of A to P, 0.2246, etc. So calculate the annual payment amount. And then, once you've done that, open up this template file that I provided and see if you can figure out how to fill out the table since I've given you these formulas. So you'll notice each one of these columns has both a title and a number. So the title explains what it is, and then the number is just kind of a shorthand for what you should do to calculate the quantity. So you're going to have to fill in some interest rate, the unrecovered balance at the beginning of the year. Hint, it's the $85,000 loan that you took. So I will tell you $85,000. And I know some of you do have computers, a few of you maybe don't, and I'd encourage you just scoot up next to somebody who does. I've emailed the template file. This template file, it's posted on Blackboard, and I also emailed it to you maybe about 45 minutes ago. So you can start with the blank workbook if you want to. There's nothing magical about this spreadsheet. It just has the titles already typed in. And I'm going to circulate around just to answer any questions as you begin to fill in the table. Okay, I have up on the screen the cash flow diagram. So what's happening is at time 0 you receive $85,000, and so that's a known amount, so solid arrow. We've labeled it as a P because it's at time 0, the amount is given. Our applicable interest rate is 4%, and then each year we have to make some equal payment to the bank. So the amount isn't known, so these are dashed arrows just to signify that. It's an A uniform annual series. All right, so we know the ratio of A to P and can calculate that the amount we're going to be giving each one of these payments to the bank is $19,093.30. All right, so now I know some of you already have that on your spreadsheet. You've already calculated it, but let me get it into the spreadsheet and on the recording in case we need to come back to it later. 4% is the interest rate. The interest on this $85,000, if we look here at the formula, it says I times 1. So that's this interest rate, and I'll anchor the reference there with the F4 button, times the $85,000. So I'm going to give the bank $19,093. Some of that will go towards interest, and some of it's going to go towards principal. The amount of it that's covering the interest, this is how much interest there is. And so the rest of that goes towards buying down the principal. So at the end of the year, we have the $85,000 that we haven't recovered and also the interest that accumulated. So it's kind of like this figure here. We started at $85,000. The effect of the interest takes us up to what? It takes us up to the sum of these two. So it says 1 plus 2. So column 1 amount plus column 2 amount. All right. And then you give the bank $19,093.30. And how much of that goes towards the principal? Column 4 minus column 2. So it's the amount that you paid minus the amount that covers the interest. So this minus that. And then the unrecovered principal balance, this last column, 1 minus 5. So at the beginning of the year minus how much of that goes towards buying down the principal. So $69,307. So then year 2 begins at the end of the previous year. So it's just going to be equals, and I click up here to this location. Now all the rest of them I don't have to type again. I can click all of these together. You can like drag down more than just a single cell. You can drag down an entire row and it will calculate all of the needed quantities. And I can do the entire thing all the way to the bottom. Oh, somehow I accidentally clicked in the wrong place. All the way to the bottom. Oh, okay. See how it's counting increased here? I need to type that in so it's always the same. 19,093 cents. And then once I've got 2 of them, I can drag down and it will keep it constant. And let me just illustrate that, show the nearest penny here. And if I show the nearest penny here, it's going to be a few cents off, but it's more or less down to 0. It means that the loan is paid off. So at the end of 5 years, if I pay the $19,093.30, then the unrecovered investment balance goes all the way to 0 after 5 years. So what we're going to be doing in future class meetings is using this same approach to calculate the rate of return on a project. You know, if you make a certain investment, you want to know what's the rate of return of that investment, what you do is you find out what is the equilibrium between the inflows and the outflows. And so this is one illustration of how we can calculate that. So any questions about this spreadsheet? My suggestion is to save it. Keep it handy because inevitably there will be a question on the homework assignment that's essentially the same thing. You just need to be able to recognize that it's the same thing that you've done before. And if you have the spreadsheet file saved, then you can use the same approach on the homework assignment. Okay, so that's all I've got for you today. Remember these next things that's kind of on the horizon. Homework 7 is due on Monday next week. We'll have a normal class on Wednesday, and then the next 2 classes after that will be recorded. Have a good day, everybody.